Hello, GrafanaCON. I'm Ivana.
Hi, and I'm Yas, and welcome to your mandatory AI talk.
And let's make it actually useful. Let's talk about what happens when your AI agent grows up. Last year, right here at GrafanaCON, we introduced Grafana Assistant, our AI agent for Grafana. We showed you how you can use it to query your data, build dashboards from scratch, and get things done in Grafana using natural language. Over the past year, it has been so great to see how many of you started to use Assistant in your day-to-day work. We've seen people sharing their experience on social media, writing blog posts, even people on YouTube racing against Assistant to see who can build the dashboard faster. Spoiler alert, Assistant wins, turning hours of work into minutes. And here are just few examples of that impact and how Assistant is changing the way people interact with Grafana.
And a year later, Assistant has grown up fast, right? We now have thousands of active users. We've merged nearly 4,000 PRs, and we went from a single team of about 9 people to more than 90 contributors across Grafana. Now, I know PRs are a bit of a vanity metric, but behind these, there are some real improvements, right? We've got better tools. We've got support for new data sources like AWS CloudWatch. We've got SQL in there as well. And also, we just expanded the capabilities that the Assistant has. So it can now utilize a knowledge graph. It can help you with your K6 load tests, or even deal with some of the IRM incidents. And we're still continuing to expand Assistant to even more corners of Grafana. But all of this growth does not come for free, right? As Assistant got larger, its behavior got less predictable, and making changes got harder as well. So today, we're going to talk about how we've overcome 3 major challenges. How we made Assistant more useful with context engineering, how we're iterating on it with confidence using coding agents and a self-improvement loop, and how we're using AI Observability to understand and trust Assistant in production.
So how do we make Assistant more useful? A big part of the answer is in context, because an AI assistant is only as helpful and as useful as the context it has. If it does not understand your system, it's going to spend valuable time trying to figure out what you have, instead of helping you with what you need. So we invested heavily in context engineering. And it comes down to 3 layers of context. First layer is what you have. Here we are talking about your dashboard, your data, your services and tables. The second layer is what you, your team, and your company knows. It's an understanding of how your team works and how your company operates. This is often captured in your runbook, triage guides, internal APIs, or documentation. And the last layer is the context about what you are doing in the moment when you are using Assistant. What task are you trying to solve? So let's start with what you have. And, well, many of you have a lot in your environment. A lot of different data sources used for different purposes, and all kinds of data. And we strongly believe that you should not have to explain all of that to Assistant every time you interact with it. So we've built the features and functionalities that bring this context to Assistant automatically. Examples of these features are dashboard scan, table discovery using your knowledge graph. But today, I would like to talk about something that we call Assistant Memories. Memories is a new capability where Assistant regularly, weekly, scans your observability data sources such as Prometheus, Loki, and Tempo. It discovers services running in your environment, groups them into logical domains, and for each of these domains, it keeps persistent memory of where things are running, how are they monitored, what are their dependencies, and top metrics. So next time when you ask Assistant a question, it does not have to start from 0. It already understands your environment. So it can just check memories and jump directly into querying relevant logs, metrics, and traces, and of course, answering your questions.
So that was context we can discover, but there's another kind we cannot, right? And it's the context that lives with you. It's how your team works, how your organization operates. It's the things that live in your runbooks, your internal APIs, or even stuff that just lives in somebody's head. So that knowledge is incredibly valuable. And that's why we've built skills. So skills allows you to capture this knowledge in Assistant, and you can even import them. Like if you have them in a GitHub repo, you can bring them in, and that makes it easier to bring in existing runbooks and docs. And because skills can reference dashboard, data sources, tools, or even other skills, they're more than just instructions. They are repeatable workflows that can be triggered directly as commands, or they can be used by the agent when it needs it. So next time, when somebody asks, like, why is my service slow and how do I fix it, Assistant can search this shared knowledge base. It can find anything relevant, pull in the right runbook, even if the user never mentioned it by name, and then that allows it to execute this task in a faster, more reliable, and repeatable way. So that means like a senior member of your team can write a triage guide once, and then every other on-call engineer on the team can then benefit from that same expertise. And with MCP integrations, skills can go even beyond Grafana, right? You can reference any MCP tool in any skill that you define. So part of your step-by-step guide could be like pull in some additional context from your AWS or your internal APIs. Or even it can take actions. So it could be like create an entry in our internal wiki.
And there is one more layer of context. It's the context about what you are doing in the moment when you are using Assistant and what are you trying to achieve. And we've solved this in several ways. Starting with hooks. We created hooks that Grafana app developers can use to pass context to Assistant automatically. So if you are, for example, in Explore page and you open Assistant, Assistant already knows what kind of data source you have selected and what's the query you've been working on. So you can just seamlessly continue your work in Assistant. But sometimes that is not enough. And we wanted to make it very easy for you, for our users, to reference what you've been working on to Assistant. So we've added one-click actions such as analyze this trace or explain this logline. If you are in dashboard, we equip dashboard with a literal pointer. So you don't have to describe what panel you would like to update. You can just point to it. And you can also attach images to your messages to Assistant. So if you ever see a beautiful dashboard that you would like to recreate, and this can be Grafana dashboard, or it can be any kind of dashboard you found on internet created by any kind of tool, you can just take a screenshot of it, send it to Assistant, and Assistant will be able to recreate it for you with your data. So yeah, more context helps a lot, but we should also acknowledge that context window is not unlimited. So let's talk about a few techniques that help us manage it effectively. Starting with deferred tools. Assistant has a lot of tools and a lot of capabilities. For those tools that are less commonly used, we use deferred loading. It means that we load tool descriptions and instructions on demand only when needed. In this case, we are still able to support a lot of capabilities, but we are saving tokens. Also, if you have a long conversation that is close to hitting context window limit, we use context compaction. This means that we keep only the most relevant and important parts of context moving forward. And last technique I would like to mention is summarization of large tool outputs. When your tool runs large query or loads large runbook, usually not every character in the runbook and not every part of that query response is relevant and adds value. So we use summarization to keep only what's relevant, what's important, and then output it in a summarized, concise way, again, helping us save tokens. So to conclude, yes, more context, and specifically more relevant context, is crucial in making Assistant actually useful. But more context also brings more complexity. And more complexity creates more opportunities for things to break. So in the end, we need to turn all of this context into predictable and reliable behavior.
Yeah, so far we talked about the things that we can do and you can do to make Assistant more useful. But like, what do you do when, despite all of this, the agent still doesn't behave like you want, right? So we put this to the test. We wanted to find out how good are AI agents really at observability tasks. So we designed a suite of tests, and then we gave an agent 3 attempts to solve each task. And then like it got a score if it passed at least once out of 3. So that's a pass rate at 3. And at 82%, that looked like a good score, like that looked promising. But then we looked at consistency. So this is about, does it solve the task not just once every 3 times, but every single time, so every 3 times. And then you see like a much bigger drop. And in software, like this would be called a flaky test, right? But in AI, this is a feature. And this makes iteration much harder because when you're making changes, you're not just changing behavior, you're also changing reliability. And you might think, well, just give the AI more instructions, right? And we did that. We tried it, but even when you literally tell the AI exactly what to do, it still doesn't consistently do it. And you can see this example from an early version of our Slack assistant. And the problem here is that it's really hard to program behavior in natural language, especially when the AI can move in mysterious ways. And this problem only becomes harder to reason about at scale. Like when you have thousands of lines of prompts and tool instructions, it becomes hard for any one person to really understand the whole system, and even harder to make changes without breaking something else. And that's a scary part of large agentic systems, right? You might be fixing one behavior, and then 3 other things that you weren't even looking at are breaking. So if only there was something, a technology, that was really good at writing and understanding language, could ingest vast amounts of information at a relatively lowish cost that may or may not be subsidized, and then surgically make changes based on your input, right? Sometimes it is the devil that you know, right? So that's what we put to the test. We thought, what if we could use AI to improve our AI?
And so we decided to send Assistant on a journey of self-improvement. And when I say self-improvement, you might be imagining something like this, that we'd made our agent do a little bit of yoga, meditation, a bit of self-discovery. Well, almost. In our case, self-improvement looks like this. It has 3 steps. First one is introspection. So first, you need to look inward. You need to discover what's good and what's bad, what's working and what's not working. Then you reflect and learn from the experience. And last step is making changes to hopefully improve. And this journey never really ends. It's an ongoing loop. And I promise I'm still talking about the AI here. So in practice, and in our case, it looks like this. The self-improvement loop is powered by coding agents such as Claude Code, paired with our internal tools and custom agent skills. They help us walk through the loop, go through a large amount of transcripts and code, and make the whole improvement process easier to run.
So let's start with the first step, right? Introspection. And honestly, it is the most important step, because if you don't know what good looks like, the rest of the journey kind of falls apart. And it's really hard evaluating agents. Like, this is a very hard step to get right, especially with observability tasks, because they can fail in very subtle ways. Like, sometimes it can generate a query that is valid, but not the right query. Sometimes, like, you ask it to create a dashboard, and it creates a dashboard, but not in the way that you asked for it. So we needed to come up with a way that was not just about evaluating the text, but actually being able to verify the outcome and the behavior. And we do this in 3 ways. Right? We have deterministic checks. So if we ask for a dashboard with 4 panels, we can check, did it create exactly 4 panels? If it mentions a trace ID, we can check, does that trace ID actually exist? So these are simple but reliable checks that we can run. The second thing that we're doing is LLM rubrics. And we use that for things that are a bit harder to encode, like express as code. So here we use an LLM judge, and we use task-specific criteria, like did it follow the right instructions? Did it find the right root cause? And these are quite helpful to validate the semantic correctness of the answer. But then finally, and this is quite special for observability, is we use these fact-based LLM rubrics. So here, we define for a task, we define what a known good query is. We run that query against a controlled environment, get the result, and then compare to what the agent did. So if the agent says latency is 2.3 seconds, but then we run our query and we get 5 seconds, we actually catch that. So this is a bit more than, oh, did the agent say the magic words? It's really about verifying if the agent did the actual work and is correct compared to the data. Now, when you put a lot of these tasks together, you get a nice little benchmark suite, and then we can use that to come up with a leaderboard. And this leaderboard is useful because it allows us to compare different models across different categories of observability tasks. And with it, we can now actually measure how reliable different AI agents are at observability tasks, instead of just relying on a few handpicked demos. Now, a lot of companies do this kind of stuff internally, but we are not a lot of companies. And also, I personally made a promise last year. So yesterday, we announced that we're introducing OliBench, right? It's our first open benchmark for observability agents. So it has everything you need to reproduce that leaderboard. It has a task, the environment, the grading logic, and even our own results. And our goal is really here to share these learnings in the open, kind of help define what good looks like, and hopefully contribute back to the broader community that's building agents around observability. So if you want to learn more about this, clone the repo. We read our blog post that is out since yesterday, and also you can always catch us after the talk. So that was introspection. Let's talk about reflection, right? Learning the good from the bad. So I showed you this already, right? This is kind of in this step, we stop looking at just the headline pass rates, and we start looking at the actual evidence. So on the right here, we can see the broader benchmark run. So we can see which task fails, which ones passed, which ones failed, and just generally where the weak spots are. But then on the right, we can drill into a specific task, and then we can look at what happened, right? We can look at which steps did the agent take, which tool calls. We can look at the entire transcript of the conversation, and also look at why the run failed or passed. So this is where the benchmark actually becomes useful, because it's not just about, oh, the score went down. It's about, here's what broke, here's the pattern, and here's what we might want to do next. Now, once we have these results, we can then run them through another coding agent. Right? These are thousands and thousands of transcripts. So again, this is where these agents can really shine, because they can ingest all of this information. And that gets us a map of what the system is good at, what it's bad at, and also where the biggest opportunities are. And that's really the core of reflection here. It's about turning this pile of results and transcripts into something that is actually useful and an actual direction for improvement. And then, as all life coaches eventually will tell us, growth requires change. Right? Change, whether that's changing the prompt, tuning the instructions, improving the tool layer, fixing bugs, or even calibrating the benchmark itself. And the better our learnings are from the previous step, the more targeted changes the agent can come up with. And once we have these proposed changes, we can just go back to the first step. Right? We can send it back through the loop to check if the changes actually helped or not, and then decide on what to do next. So the final call still remains with us humans. Right? So the coding agent proposes, the benchmark verifies, and then we can focus on reviewing, validating, and then merging those changes. And that's how we improve agents with confidence. And the journey never really ends there. As the agent gets more capabilities, we can run it through the loop again, and that allows us to continuously optimize for cost, latency, quality, reliability. And all of this is powered by coding agents and that feedback loop. But even the best benchmark, it only tells you how it works in a controlled environment, but the real world is a bit different. You still have real users that interact with Grafana in their very own, sometimes weird ways. So once we ship, there's still one final mountain to conquer, and that is production.
So how do we conquer that mountain? The last question we need to answer is what happens once Assistant leaves the lab and starts dealing with the real users in a real world? That's why we've built Grafana AI Observability, our new database and platform for observing AI agents. You could already see parts of it in yesterday's keynote. It connects our experience building agents with our experience building observability systems. With Grafana AI Observability, we've built something that we needed, something that helps us understand our agents, including Grafana Assistant in production. So I'll be doing a live demo for this. But before I start the demo and before my screen loads, I would like to say two things. First one is that Grafana AI Observability is in public preview. So everything that I will be showing you today, you can test, you can try with your agent as soon as today. Also, if we can get
switch the demo.
Working. So
is it working?
OK, yeah. So we wanted to make it very easy for you, for our users, to start with Grafana AI Observability. So if you go to Start Up, you can see all of the instructions you need to set up. We also created agentic skills. So if you are using Cursor, Claude Code, or Copilot, you will be able to instrument your apps within a minute, and you will be able to send your telemetry to Grafana AI Observability very fast. So now let's have a look. This is where we analyze our AI agents, including Assistant, and answer questions such as how many tokens are being used, what is the error rate, time to the first token, or very important metric, what are costs associated with all of my agents. Grafana AI Observability has a lot of features, but today I will be focusing on online evaluations. Because with online evaluations, we can answer that last question, which is how is Assistant behaving when it's used by real users? Because in practice, users are using AI agents in unpredictable ways. And we still want to make sure that our AI agent assistant is responding correctly and securely. So first step is deciding what correct behavior means to us. And this is where we set up our evaluators. So first evaluator I'm setting up is an LLM judge. So we are going to be using another LLM to judge our LLM, our AI agent. And here we want to make sure that Assistant grounds its answers in real data and that it does not hallucinate. The second evaluator I'm setting up is more security-oriented evaluator. So here we are evaluating whether users are trying to do prompt injection on our assistant. And in the case we detect it, we can review conversations and make sure that assistant responded securely. Last evaluator I'm setting up is more simple one. So this is a heuristic one. And we are just checking the length of the response. So here we want to make sure that assistant is not showing a wall of text to our users that nobody would read, and that it nicely summarizes the data. You could also create a new evaluator based on your agentic needs, based on what do you care about, and either start from scratch, or we also created a lot of templates that you can choose from. So now when we have our evaluators, we need to decide where are these evaluations, on which conversations are they going to be running. So let's select our Grafana Assistant, and in this case, 20% of Grafana Assistant generations that are user visible are going to be evaluated by our evaluators. We also added very simple integration for alerts. So basically, with 2 clicks, you can also add alerting. And in this case, if pass rate falls under 80%, we will get notified. So we will learn if something goes wrong with our agents. And we can start scoring. So as you can see, I created very similar evaluation role before, so we can have a look at the results. I'll update the time range. And so now we have a data, a measurable way how we can detect how is assistant behaving. We can monitor trends. We can even, we set up alerts, so we will get notified if something goes wrong. And we are even able to drill down into those specific conversations that failed evaluation. So we can have a look at one of those. So this will take us to conversation view, where we can see all of the information about the conversation. We can see how user was communicating with our agents. We can see the metadata. And we can see all of the evaluations that were run on this conversation. So as you can see, most of them passed, but there is one that failed, which is groundedness. We get also information here why it failed. So you get more insights into why this LLM judge considered this 5 out of 10. In this case, user was asking to create a new alert role for infinity data source. But what is LLM judge telling us is that it provided a good query, but it didn't double check what the query structure looks like. So we need to evaluate if this is a bad behavior or if it's fine. And if it's bad behavior, is it a one-off case, or is it actually a pattern that has been happening over time? And if it's a pattern, if we've noticed that this has been happening multiple times, we should turn this into test case scenario, bring it into our self-improvement loop, and make sure that we fix this in future iterations. And so this is how we are observing our AI agents in Grafana in actually useful way. This is the end of my demo, and I would like to say that if you are building agents, and if you are interested in AI observability, go and test it out, or you can join us in our AI demo station, and we will be more than happy to show you more features from Grafana AI observability.
Let's go back to slides. Do we switch back to slides? Yes. It's you? Okay. So that was our story. So as we scaled up Assistant, we had to solve these three harder problems, right? How to make it more useful with context engineering, how we iterate on it with confidence with these self-improvement loops, and how we trust and understand it in production with AI observability. And I'm going to leave you with this, right? Better agents and better agentic systems are not just about bigger, larger, more expensive models. It's also about providing more relevant context. It's about building and using good improvement loops so that you can tune them. And also, it's about observing your agents in production. And that's how you move from something that's just like an impressive demo to something that is actually useful. Thank you.